Welcome friends, welcome back to the top 40 Kubernetes interview questions and answer. So the first question is, what is Kubernetes and why is it used? Let's see the answer. Kubernetes is an open source platform for automating deployment, scaling, and operations of application containers across clusters of hosts. It simplifies the management of containerized applications by providing self-healing, scaling, and deployment capabilities. It helps ensure high availability and load balancing. Let's move to the second question. Explain the architecture of Kubernetes. Let's see the answer. Kubernetes architecture consists of a master node and worker nodes. The master node includes components like the API server, etched, key value store, scheduler, and controller manager. Worker nodes run the kubelt, agent, and Kuber proxy, managing the actual containers. This architecture ensures effective cluster management and resource allocation. Let's move to the third question. What is a Kubernetes pod? Let's see the answer. A pod is the smallest deployable unit in Kubernetes, representing a single instance of a running process in the cluster. It can contain one or more containers that share the same network namespace, storage, and specifications. Pods abstract application containers and manage their life cycles. Let's move to the fourth question. What are deployments in Kubernetes? Let's see the answer. Deployments provide declarative updates to applications, defining the desired state and enabling automated rollouts and rollbacks. They manage the creation and scaling of pods, ensuring the application remains available during changes. Deployments facilitate easy updates and scaling operations. Let's move to the fifth question. What is a Kubernetes service? Let's see the answer. A service in Kubernetes defines a logical set of pods and a policy by which to access them. Services provide load balancing, IP address assignment, and DNS capabilities to ensure pods can communicate with each other or with external systems. They abstract the underlying pods and ensure stable network endpoints. Let's move to the sixth question. What is a replica set in Kubernetes? Let's see the answer. A replica set ensures a specified number of pod replicas are running at any given time. It maintains the desired state by creating or deleting pods as necessary. Replica sets are often used by deployments to manage the scaling and availability of applications. Let's move to the seventh question. Explain config maps and secrets in Kubernetes. Let's see the answer. Config maps store configuration data in key-value pairs, decoupling configuration artifacts from image content. Secrets are similar, but are designed to store sensitive data like passwords or tokens securely. Both are used to pass configuration data and secrets to pods. Let's move to the eighth question. What is a stateful set? Let's see the answer. A stateful set is a Kubernetes controller that manages stateful applications. It provides guarantees about the ordering and uniqueness of pods, ensuring each pod has a stable, unique identity and persistent storage. Stateful sets are used for applications requiring stable networking and storage. Let's move to the ninth question. What are daemon sets? Let's see the answer. A daemon set ensures that a copy of a pod runs on all or some nodes in the cluster. It is used for deploying background tasks like log collection, monitoring, and other node-specific services. Daemon sets facilitate centralized management of node-level tasks. Let's move to the 10th question. What is a Kubernetes ingress? Let's see the answer. An ingress is a Kubernetes object that manages external access to services within a cluster, typically HTTP. It provides load balancing, SSL termination, and name-based virtual hosting. Ingress controllers manage the routing rules defined by ingress resources. Let's move to the 11th question. How does Kubernetes handle container networking? Let's see the answer. Kubernetes uses the Container Network Interface (CNI) to manage networking, providing each pod with a unique IP address. This ensures pods can communicate with each other without NAT. Various CNI plugins, G, Flannel, Calico, can be used to implement network policies and routing. Let's move to the 12th question. What is the role of etched in Kubernetes? Let's see the answer. Etched is a distributed key-value store used by Kubernetes to store all cluster state data. It provides a consistent and highly available data store for configuration, state, and metadata, ensuring the control plane has the necessary information to manage the cluster. Let's move to the 13th question. Explain Kubernetes namespaces. Let's see the answer. Namespaces are a way to divide cluster resources between multiple users or teams. They provide a scope for names, ensuring resource names are unique within a namespace but not across namespaces. Namespaces enable resource isolation, access control, and efficient resource management. Let's move to the 14th question. What are Kubernetes volumes? Let's see the answer. Kubernetes volumes provide persistent storage to pods, enabling data to persist across container restarts. Various volume types, e.g., empty dir, host path, persistent volume claim, support different use cases, from temporary storage to long-term, durable storage solutions. Let's move to the 15th question. What is the Kubernetes control plane? Let's see the answer. The control plane manages the Kubernetes cluster, making decisions about the cluster, scheduling, scaling, and responding to cluster events. It includes components like the API server, scheduler, controller manager, and etched. The control plane ensures the desired state of the cluster is maintained. Let's move to the 16th question. How do you secure a Kubernetes cluster? Let's see the answer. Securing a Kubernetes cluster involves using network policies, RBAC, role-based access control, and TLS for API server communication. Additionally, you should secure etched, use namespaces for resource isolation, regularly scan for vulnerabilities, and follow best practices for container security. Let's move to the 17th question. What are Kubernetes operators? Let's see the answer. Operators are software extensions that use custom resources to manage applications and their components. They encapsulate operational knowledge in code, automating complex tasks like backups, upgrades, and scaling. Operators extend Kubernetes capabilities beyond basic container orchestration. Let's move to the 18th question. What is a persistent volume, PV, and persistent volume claim, PVC? Let's see the answer. A persistent volume, PV, is a piece of storage in the cluster that has been provisioned by an administrator. A persistent volume claim, PVC, is a request for storage by a user. PVCs abstract storage requests, enabling dynamic provisioning and decoupling storage management from pods. Let's move to the 19th question. How do you perform a rolling update in Kubernetes? Let's see the answer. Rolling updates are managed by deployments, which update pods incrementally with zero downtime. You can specify the update strategy and parameters, e.g., max surge, max unavailable, to control the rollout process. Kubernetes automatically manages pod replacement and traffic routing during the update. Let's move to the 20th question. What are custom resource definitions, CRDs? Let's see the answer. CRDs allow you to define custom resources to extend Kubernetes functionality. By creating CRDs, you can manage custom application configurations and behavior within the Kubernetes API, enabling the creation of custom controllers and operators for specialized workloads. Let's move to the 21st question. What is Helm in Kubernetes? Let's see the answer. Helm is a package manager for Kubernetes that simplifies the deployment and management of applications. It uses Helm charts, which are collections of YAML files that define a set of Kubernetes resources. Helm supports versioning and rollback, enabling easier updates and maintenance. It also provides templating for reusable configurations, streamlining complex deployments. Let's move to the 22nd question. What is a Kubernetes job? Let's see the answer. A Kubernetes job ensures that a specified number of pods complete successfully, typically used for batch processing tasks. The job controller creates pods and monitors their execution, restarting them if they fail. Once the specified number of completions is achieved, the job terminates. This ensures reliable and repeatable task execution within the cluster. Let's move to the 23rd question. What are Kubernetes init containers? Let's see the answer. Init containers are specialized containers that run before the main application containers in a pod. They perform setup tasks like initializing data or checking dependencies. Each init container must complete successfully before subsequent init containers or application containers start. This ensures that the pod environment is properly prepared. Let's move to the 24th question. How does Kubernetes handle secrets management? Let's see the answer. Kubernetes secrets store sensitive data such as passwords, tokens, and keys. They can be mounted as volumes or accessed as environment variables within pods, keeping sensitive information separate from application code. Secrets are encoded in base 64 and can be encrypted at rest, enhancing security. Access to secrets is controlled via RBAC. Let's move to the 25th question. Explain horizontal pod autoscaling, HPA. Let's see the answer. Horizontal pod auto-scaling, HPA, adjusts the number of pod replicas based on observed CPU memory utilization or custom metrics. HPA helps maintain application performance and resource efficiency by scaling pods up or down in response to workload changes. It continuously monitors metrics and adjusts the number of replicas to match demand. This ensures optimal resource usage and availability. Let's move to the 26th question. What is a Kubernetes cluster IP service? Let's see the answer. A cluster IP service is the default type of Kubernetes service, exposing the service on an internal IP address within the cluster. This allows pods to communicate with each other but is not accessible from outside the cluster. Cluster IP services provide a stable endpoint for internal service discovery. This internal-only access helps secure internal communications. Let's move to the 27th question. What is a Kubernetes node port service? Let's see the answer. A node port service exposes a Kubernetes service on a static port on each node's IP, making it accessible externally. This service type maps an internal cluster IP service to a high port on each node. It allows external clients to access the service using the node's IP and the assigned port. Node port services are typically used for development and testing due to limited scalability. Let's move to the 28th question. What is a Kubernetes load balancer service? Let's see the answer. A load balancer service exposes a Kubernetes service externally using a cloud provider's load balancer. It provisions an external load balancer that distributes traffic to the service's pods. This provides a single IP address for external access, simplifying client connections. Load balancer services are ideal for production environments requiring high availability and traffic management. Let's move to the 29th question. What are Kubernetes persistent volumes, PV, and persistent volume claims, PVC? Let's see the answer. Persistent volumes, PV, are storage resources provisioned in the cluster, while persistent volume claims, PVC, are requests for storage by users. PVCs allow pods to request specific storage resources without knowing the details of the underlying storage infrastructure. This abstraction enables dynamic storage provisioning and management. PVs and PVCs together provide persistent storage that survives pod restarts. Let's move to the 30th question. How do you perform a canary deployment in Kubernetes? Let's see the answer. Canary deployment in Kubernetes involves gradually rolling out a new version of an application to a small subset of users before a full deployment. This can be achieved by creating a new version of a deployment and gradually shifting traffic using service mesh tools like Istio. It allows teams to monitor performance and catch issues early. Traffic can be incrementally increased to the new version if no issues are detected. Let's move to the 31st question. What is a Kubernetes service mesh? Let's see the answer. A service mesh is an infrastructure layer that manages service-to-service communication within a Kubernetes cluster. It provides features like load balancing, service discovery, encryption, and observability. Service mesh tools like Istio deploy network proxies alongside application services to handle communication. This abstraction simplifies microservices management and enhances security and reliability. Let's move to the 32nd question. Explain Kubernetes pod disruption budgets, PDB. Let's see the answer. A pod disruption budget, PDB, specifies the minimum number or percentage of pods that must be available during voluntary disruptions, such as maintenance. PDBs help ensure application availability by preventing too many pods from being taken down simultaneously. They protect against disruptions affecting application performance. PDBs are defined per application to maintain stability. Let's move to the 33rd question. What is Kubernetes Federation? Let's see the answer. Kubernetes Federation allows managing multiple Kubernetes clusters as a single entity. It provides centralized control over clusters, enabling workload distribution and disaster recovery. Federation supports global application deployments across different regions or cloud providers. This ensures high availability and fault tolerance by replicating resources. Let's move to the 34th question. How does Kubernetes handle container logging? Let's see the answer. Kubernetes captures container logs by redirecting standard output and error streams to the logging driver configured on the node. Logs can be accessed using kubectl logs for individual pods. For centralized log management, logging agents like Fluent can collect and forward logs to systems like Elasticsearch and Kibana, EFK Stack. This provides comprehensive logging and analysis. Let's move to the 35th question. What is a Kubernetes admission controller? Let's see the answer. An admission controller is a piece of code that intercepts requests to the Kubernetes API server before they are persisted in etched. Admission controllers can validate, modify, or reject requests based on predefined policies. They enhance security and policy enforcement by ensuring compliance with organizational rules. Admission controllers operate as plugins for flexible policy implementation. Let's move to the 36th question. What is a Kubernetes endpoint? Let's see the answer. An endpoint is an object that represents a set of IP addresses and ports associated with a Kubernetes service. Endpoints track the addresses of the pods that back the service, ensuring that traffic is correctly routed. They update dynamically as pods are added or removed, maintaining accurate service discovery. Endpoints are crucial for internal communication within the cluster. Let's move to the 37th question. What is a Kubernetes stateful set? Let's see the answer. A stateful set is a Kubernetes controller that manages the deployment and scaling of a set of pods with unique, stable identities. It provides guarantees about the ordering and uniqueness of pods, making it ideal for stateful applications like databases. Each pod in a stateful set has a persistent identifier and storage, ensuring data is retained across pod rescheduling. Let's move to the 38th question. What are Kubernetes annotations? Let's see the answer. Annotations are key-value pairs attached to Kubernetes objects that store non-identifying metadata. They can be used to attach arbitrary information such as build or deployment details, or configuration information for external tools. Annotations are not used to identify or select objects, which distinguishes them from labels. Let's move to the 39th question. What is the role of the Kubernetes API server? Let's see the answer. The Kubernetes API server is the central management entity that exposes the Kubernetes API. It processes RESTful requests, validates them, and updates the cluster's state in etched. It serves as the front end for the Kubernetes control plane, facilitating communication between various components and users. Let's move to the 40th question. How does Kubernetes ensure high availability? Let's see the answer. Kubernetes ensures high availability through features like replica sets, which maintain a specified number of replicas for each pod, and by distributing pods across multiple nodes. Additionally, it supports multi-master setups, allowing the API server to remain available even if some instances fail. Health checks and automatic rescheduling of failed pods further contribute to high availability.
If you have any question or any doubt, feel free to ask in the comment section below. I will answer you as soon as I can. Thank you for watching. Bye and have a nice day.